sample of ash from Eyjafjallajökull in Iceland, the country I'm from. And I find it fascinating that although our planet started with volcanic ash, lava, and just oceans, we are now teeming with life. And that is all about chemistry, really. And my fascination is about what I call complexity in chemistry. How do complicated, complex chemical systems gain function and can be as simple as self-assembly of one type of peptide into a macroscopic material. These are the sort of things that I'm interested in systems chemistry. And one area in particular which relates to the origin of life are protocells. That is sort of primitive cell-like containers that have some of the functions that we recognize in life. And if we start to build these things more and more complicated, we will eventually see how we can bridge from the chemistry world over to the biology world. So I'm going to show you now a little bit more what we're doing in our research on protocells, which are based on polymers. So the protocells are like vesicles. So protocells that self-assemble from polymers have very similar structures to the ones that form from small lipids and we know as vesicles or liposomes. So in this case, you also actually get a bilayer from the amphiphilic block of polymers. And what we've been interested in is to take then membrane proteins and encapsulate in these polymosome membranes. And in particular, looking at functional membrane proteins, such as proton pumps, like cytochrome C oxidase. What we've done then is to link little light harvesting units to these proton pump proteins, so that when we bring in light here, we can turn on these proton pumps. And for instance, in this case, we might pump protons out of these polymosomes. And then what you will have, of course, is that you will see the pH here inside that polymosome will have gone up. Now imagine then, if you had on top of that, you would have some molecules inside, trapped inside these polymosomes. And then when the pH drops in here, they start to, they start to self-assemble into structures. And these are the sort of functional systems we're trying to build and mimic, for instance, the formation of the cytoskeleton from actin proteins inside the cell.